Okay, class, welcome to graphing secant and cosecant. We're going to start off with graphing secant. So things we need to remember that secant is the reciprocal of cosine function. So when we're going to graph our secant function, we're first going to graph our cosine function. So in the diagram, we can see that our cosine function is our U-shaped function. That is in our light gray. And then the secant function is its reciprocal. So when we are going to be graphing our secant function, we're first going to graph our cosine function, and wherever we see a maximum of our cosine function, we are going to do our upside down U. Whenever cosine crosses the x-axis, it has a intercept. We are going to do a asymptote for our secant function. So wherever cosine crosses the x-axis or our horizontal axis, if there is a vertical shift, we will have our asymptotes for secant. Wherever cosine has a maximum, our secant function will have this relative minimum point. And wherever our cosine function has this minimum value, our secant is going to have this little maximum value there. Okay, so I talked about when cosine crosses the midline, secant will have an asymptote, and we're going to always draw our asymptotes with dashed lines. And I talked about when cosine has a maximum, which would be example here and here, then our secant is going to have what's called a relative min, and we're going to draw in this U shape with the relative min. And similarly, whenever cosine function has a minimum, our secant function is going to have what's called a relative maximum. We're going to have this U-shaped. When we look at our secant function, we are seeing that our secant function is the dark part mixed with the asymptotes. It's not in here. This is our cosine function. Our domain, I can see that the domain has x values. For all of them, it's defined except for the asymptotes. So it's not defined at minus pi over 2. It's not defined at pi over 2 or at 3 pi over 2. Our secant function is not defined wherever there's an asymptote, so it's always going to be all real numbers except for our asymptote equation. So let's talk about how we get this asymptote equation. Those are always the same. So in order to write your asymptote equation, we always look for our first non-negative asymptote. So our first non-negative asymptote would be right here, which is pi over 2. And then n times this number here is always the distance to the next asymptote. So when we look at the distance to the next asymptote, one's at pi over 2 to 3 pi over 2. This distance is pi. It's pi n. It's all multiples of pi. We're going to add to pi over 2. So we're going to do pi over 2 plus 1 pi, plus 2 pi, plus 3 pi. We're going to keep adding multiples of pi, and also negative multiples of pi. So pi over 2 minus 1 pi, minus 2 pi, minus 3 pi, because every pi there's going to be an asymptote. So that's how you write the equation for the vertical asymptote, and the domain would be all real numbers except for wherever there's an asymptote. The range, we can see it goes from minus infinity up to this value, which is minus 1. So it's defined here. So from minus infinity to minus 1, including minus 1, so we have a square bracket to indicate that it does include that value. And then again, it's not in here, because that's our cosine function, but it starts at 1 and goes up to infinity, including 1. So it's going to be a square bracket around the 1, and it goes all the way up to infinity. We always write the range in this interval notation. If it includes the value, it's a square bracket. If it does not include it, it would be a round bracket. Our period is going to be 2 pi over b in general. Since the b value was 1, it would be 2 pi. And the y-intercept would be where it crosses the y-axis, which is at 0, 1. So this would be the y-intercept unless there, of course, is some sort of horizontal phase shift. Okay, let's go ahead and graph the first problem. So the first problem says to graph a negative secant function. So to do this, the first step is to find all the information about the cosine. So we know that it's a negative cosine function and negative cosine functions. A negative cosine function looks like an upward, downward facing U. So we're going to graph our negative cosine function. We know that the period would be 2 pi over b, which in this case is 2. So I found my period. I need to find my x-axis scaling, and it's always period over 4. It's going to be the same idea. My a is -3, so my amplitude is 3. So I know I'm going to go down to -3, and I'm going to have my minimum, then it's going to go up to the middle, and then it's going to go to the maximum at 3. So I'm just graphing my negative cosine function, and I'm going to go ahead and just graph it as far as it can across this graph paper. In both directions. So I'm going to graph my cosine function. So this is a negative cosine function, and I'm actually graphing 3 full periods of my negative cosine function here. Okay, so this is the graph of y equals -3 cosine of 2x. Okay, so that was step 1. Graph the cosine function that it's related to. We found the period was pi, and its x-axis scaling was pi over 4, so that's 1 pi over 4, 2 pi over 4, 3 pi over 4 pi. So I do see that 1 period of cosine went a distance of pi, and I'm going to continue filling out my x-axis scaling. Okay, so now that I have my x-axis filled out, I'm going to go ahead and graph my secant function. So wherever cosine crosses the midline, my secant function is going to have a vertical asymptote. So I'm going to draw my vertical asymptotes always with dashed lines. So wherever your function crosses the midline, in this case the midline is the x-axis since there was no vertical shift. But of course if there was a vertical shift, we would look to see where the cosine function crosses the midline. Okay, so we've drawn in all of our asymptotes, and then wherever we have a cosine function with a max, secant is going to have a u-shaped with the minimum. And wherever our cosine has this minimum, our secant is going to have the u. So now I've switched colors so I can easily identify which function is which. This is where it should be connecting, so I have to fix my cosine function since I was slightly off there. So it's going to go and touch and come back down. So it should look like that. And I'm going to continue doing my u's all the way across. Okay. So you notice in the assignment I didn't specify how many periods I'm going to graph, but the period is going to include these u-shapes and these asymptotes. So we're going to have 5 things. We're going to have an asymptote, a u, an asymptote, and a downward u, and an asymptote. 5 things. Asymptote u, asymptote u, asymptote. So that's 5 things for 1 period. So this right here would be 1 period of a secant function. Okay, so now we're going to write the equation for the asymptote. The equation for the asymptote is x equals, so we would look for the first non-negative asymptote, and that is at pi over 4. So the first non-negative asymptote plus n, it's always n, and then we look for the distance between your asymptotes, and the distance between the asymptotes would be half of a period. It's always going to be half of a period. So this is the distance between the asymptotes, which is from pi over 4 to 3 pi over 4, which is pi over 2. So that's going to be the equation for the asymptotes. So then now we're going to find the domain. The domain is always going to be all real numbers. You could of course write out the name all real numbers, and then I'm going to say except where the asymptotes were, which is pi over 4 plus n pi over 2, because wherever there's an asymptote is of course where the function is undefined. And then we're going to find the range, and we're going to write an interval notation. So it goes from -infinity all the way up to this -3 value, and it includes -3. So it's a square bracket union. But it's not in here, because that's my cosine function. So it's up here at +3 all the way up to infinity, and it includes +3. Technically, you can never reach infinity or -infinity, which is why it is a round bracket. Okay, let's go ahead and flip our pages over and go to cosecant. Okay, so now we're going to graph cosecant, and cosecant is the reciprocal of sine. So whenever we want to graph cosecant, we're first going to graph our sine function. Wherever sine crosses the midline, we're going to draw an asymptote of cosecant. Wherever our sine function has a max, we're going to draw our u for our cosecant function. And then we're going to draw our u whenever there is a minimum. It's going to be everything is identical, including the domain and range. It's the same idea. Okay, so let's go ahead with our first example. Okay, so we're going to go ahead and graph this cosecant function. So we see that it's cosecant, so I know I need to graph first the related sine function. And the related sine function is y equals 2 sine of x over 2 minus 1. So I know I'm going to have a vertical shift, down 1. I know I have a period change. The period is 2 pi over b, which is 1/2. So my period is 4 pi. And my x-axis scaling is going to be in terms of period over 4, which is pi. There is no phase shift. My amplitude is going to be 2. And my shape, because it is a sine function, sine starts at the origin and goes up. So I'm going to go ahead and graph my sine function for the entire length of the video, or the length of the screen. So go ahead and pause the video and do that. So here I went ahead and graphed my sine function. It had a vertical shift down 1, so you can see my midline here down at -1. It's a sine function, so it starts on the midline and it goes upward. It had an amplitude of 2, so it went up 2 units. And then it goes down 2 units. So I graph my sine function all the way. So then I'm going to do its related secant function, cosecant function. So wherever it crosses the midline, I'm going to draw my cosecant's vertical asymptotes. So I'm going to draw in all of my vertical asymptotes. Now wherever there is a maximum of my sine function, my cosecant is going to have the U shape. So I'm going to graph those. And I'm going to do it on both sides. And one period, again, contains the 3 asymptotes, one upward and one downward U. So this is one period, including an asymptote and the U's. So the period was 4 pi, which we found. The equation for the asymptote is x equals, we look for the first non-negative asymptote, which is 0, plus n, the distance between the asymptotes. So the next asymptote is at 2 pi, which can also be written as n2 pi. You don't have to write the 0. So the first non-negative, which includes 0. The domain is all real numbers, except for the asymptote, which is x equals n2 pi. You could, of course, also write this as just 2 pi and all multiples of 2 pi. The range goes from -infinity, it goes up to -3. It includes -3. Union. It's not in here where my sine function is, but it starts up at 1 again and goes all the way up to infinity, including infinity. And that would be the range. Okay, thank you and have a good night.